Welcome to the first class of computer programming and numerical methods. So today I will give you an idea about the numerical technique called Gauss Elimination method. So Gauss Elimination method is actually basically the most effective direct solution technique. So this is actually used for solving linear algebraic equations. So a system of m linear equations will be there. You have to solve this linear algebraic equation. So here you can see these are the linear algebraic equations: a11 x1 plus a12 x2 etc. This is the first equation. a21 x1 plus a22 x2 plus etc. This is the second equation, etc. So these are the system of m linear equations. So this is the most effective direct solution techniques. Currently being used are applications of Gauss elimination method, which Gauss proposed over a century ago. In this method, the given system is transformed into an equivalent system with upper triangular coefficient matrix, that is a matrix which all elements below the diagonal elements are 0, which can be solved by back substitution. So this is the method. So I will explain with the help of an example. So here you can see problem number 5.6. Solve the system of equations 28x plus 4y minus z is equal to 32, x plus 3y plus 10z is equal to 24, 2x plus 17y plus 4z is equal to 35 using Gauss elimination method. So first you have to write the given system in augmented matrix form. So augmented matrix means the coefficient. You have to write this this matrix with the help of this coefficients. So what is the coefficients of the first equation? 28, 4, minus 1, 32. So here you can see the first row 28, 4, minus 1, 32. Then 1, 3, 10, 24. So 1, 3, 10, 24. And the next one 2, 17, 4 and 35. 2, 17, 4 and 35. So here I will apply the some transformation. So here you can see I will divide the first row by 28. So I will divide the first row by 28, that is r1 tends to r1 divided by 28. That is the first thing. So 28 by 28, so it is 1. Then next is 4 by 28, then minus 1 by 28 and 32 by 28. So that is the first thing. R1 tends to R1 divided by 28. Then the next is I will change R2 tends to R2 minus R1. So this is the second row, R2 minus R1. So you will get matrix like this. R2, this is the second row, 1, 3, 10, 24. This is the second row and this is the first row. So R2 tends to R2 minus R1. So 1 minus 1 is 0. So then this thing minus this thing. Okay, you will get this value. Then R3 tends to R3 minus 2R1. So R3 means this is the R3, 2, 17, 4, 35. This is the R3 and this is minus 2R1. So this is the 2R1. You have to multiply the first row with 2. So then only this term will be converted into 0. So 2 minus 2. Okay, R3 minus 2R1. Yeah. Then here you can see I will interchange the R3 and R2. So now you can see I will interchange R3 and R2. Then I will apply R2 tends to R2 multiplied by 7 by 117. So now this term will becomes 1. Then next is R3 tends to R3 minus 20 by 7 R2. So this becomes 0. Then R3 tends to R3 multiplied by 156 by 1457. Okay, so now you can see the all elements below the diagonal elements are 0. Okay, then which can be solved by back substitution. Now you can see this is the diagonal element, all the diagonal elements are 0, which can be solved by back substitution. So here you can see this term is 0, this term is 0, and this term is 0. Then first you have to select the last row. So Z is equal to 1.8485. so here the first term is 0, so second term is 0, so 0x plus 0y plus 1z, so 1z is equal to 1.8485. so the value of z is equal to 1.8485. then the second row, 0x plus 1y, so 1y means y, then y plus 19 by 78 z, so this time is z is equal to 229 by 17. So z, you already know what is the value of z, 1.8485. substitute here, you will get the value of y. Then take the first row, 1 plus 1 means x plus 1 by 7 y minus 1 by 28 z is equal to 8 by 7. So you have to substitute the value of y and z into this equation, you will get the value of x. So the value of x is 0.99, y is 1.0, and z is equal to 1.84y. So this is the method involved in Gauss elimination method. Another example, so here this is the system of equations. So here this is the linear system of equations, a11 x1. so this is the linear system of equations. So 10x minus 2y plus 2z is equal to 23, 2x plus 10y minus 5z is equal to minus 33, 3x minus 4y plus 10z is equal to 4. So you have to write the matrix in augmented matrix. So that means the coefficient matrix 10 minus 2, 2, 23, 10 minus 2. So here this is not this equation is not 2, this is 3, so 3, 23, then 2, 10 minus 5 minus 33, 3 minus 4, 10, 41. Then apply row transformation. First you have to divide the first row with the 10 such that this value becomes 1, so r1 tends to r1 by 10. Then next is you have to do some row transformations, that is r2 tends to r2 minus 2 r1, r3 tends to r3 minus 3 r1. Similarly r2 tends to r2 divided by 52 by 5, r3 tends to r3 divided by 17 by 5 r2, r3 tends to r3 divided by 189 by 6. So such that you can see this is the diagonal element. So the diagonal element is 1 1 1, and the terms below the diagonal element is 0 0 0. Okay, so this is the method in Gauss elimination method. So then take the last row, that is z is equal to 3. This is called a back substitution, z is equal to 3. Then take the second row, y minus 7 by 13, z is equal to minus 47 by 13. Then you have to substitute the value of z here. So z value is 3, you will get the value of y, so y is equal to minus 2. Then take the first row, x minus 1 by 5 y plus 3 by 10 z is equal to 23 by 10. Here you can see this is the equation, x minus 1 by 5 y plus 3 by 10 z is equal to 23 by 10. Okay, you have to substitute the value of y and z here, you will get the value of x. Okay, finally the value of x is equal to 1, y is equal to minus 2, and z is equal to 3. Then another equation, again this is another equation, 3x plus y minus 2 is equal to 3, 2x minus 8y plus z is equal to minus 5, and x minus y plus 9z is equal to 8. First you have to write the augmented matrix, that is the coefficient matrix. Then you have to give the row transformation. Okay, first is r1 tends to r1 divided by 3, then r2 tends to r2 minus 2 r1, r3 tends to r3 minus r1, r2 tends to r2 plus minus 26 by r3, r3 tends to r3 plus 7 by 3 r2, r3 tends to r3 plus 231 by 26. Okay, so now you can see all the values under the diagonal becomes zeros, so 0 0 0, so back substitution. So z, consider the third row, z is equal to 1, so here you can see z is equal to 1. Then next equation, y minus 5 by 26, z is equal to 21 by 26. You have to substitute the value of z here, you will get the value of y. Then y x plus 1 by 3 y minus 1 by 3 z is equal to 1. Substitute the value of y and z here, you will get the value of x. So the value of x is 1, y is equal to 1, z is equal to 1. So this is another equation. Okay, x1 plus x2 plus x3 plus 4 is equal to 2, like this. Okay, first you write the augmented matrix, coefficient matrix, then row transformations. So here you can see this is the row transformation. So here I will interchange second row and third row. Then again row transformations, r4 tends to r4 minus r2, r3 tends to r3 divided by r2, r4 tends to r4 minus 3 r3, r4 tends to r4 divided by 5 by 2. So now you can see this is the diagonal elements, this is the diagonal elements. So under that all these values 0. So take the last row, z is equal to the z. So here it is not z. So here the variable is x1, x2, x3 and x4. So the fourth variable is x4. So the value of x4 is equal to, so the value of x4 is equal to 2. Then take the third row. So x3 minus 3 by 2 x4 is equal to minus 4. x3 so here x3 minus 3 by 2 x4 is equal to this value. Okay, then next is next equation, x2 minus 3x3 plus 0x4 is equal to 3. Then back substitute here, you will get the value of x2. Then the first row, x1 plus x2 plus x3 plus x4 is equal to 2. x1 plus x2 plus x3 plus x4 is equal to 2. Substitute the value of x2, x3 and x4 here, you will get the value of x1. Okay, so this is the method involved in Gauss elimination method. So once again, in Gauss elimination method, the given system is transformed into an equivalent system with the upper triangular coefficient matrix, that is a matrix in which all elements below the diagonal elements are 0, which can be solved by back substitution. So the system of m linear equations or a set of m simultaneous linear equations in n unknowns, x1, x2, x3 etc. is a set of equations of the form a11 x1 plus a12 x2 plus etc. a1 and etc. So where a11, a12, a1n are called coefficients of x1, x2 etc. Where the coefficients of x1, x2 etc. xn are b1, these are the constants. So this b1, b2, b are called constants. So first you have to write the system of equations into an augmented matrix form, like a matrix. Here you can see a11, a12 etc. So here you can see, so this is the system of equations. You have to write the system of equations in augmented matrix form. Okay, so for solving this system of equations, there will be two methods. One is direct method and second one is indirect method. So Gauss elimination method, Gauss-Jordan method belongs to the direct method, and Gauss-Jacobi, Gauss-Seidel method belongs to the iterative methods. So this Gauss-Jacobi and Gauss-Seidel methods are actually iterative methods, iterations. This Gauss elimination, Gauss-Jordan method are called direct methods. I hope the steps is actually clear. Okay, then I will move to the university question paper. Okay, so question number 10, here you can see 10-mark question. Solve the system of linear equations by Gauss elimination method. So 3x minus 2y plus is 8z is equal to 9, minus 2x plus 2y plus z is equal to 3, x plus 2y minus 3z is equal to 8. So you have to solve this. So first you have to complete the problems I have explained in notebook, then you have to solve this. Then another question is again question number 9. Solve the following system of equations using Gauss elimination method. x plus y plus z is equal to 9, 2x minus 3y plus 4z is equal to 13, 3x plus 4y plus 5z is equal to 40. So you have to solve this equation. Then another one, question number 9a, give the step-by-step procedure for solving algebraic equations by Gauss elimination method. Okay, so what are the steps involved for solving the algebraic equations by Gauss elimination method? So you have to find the solution, okay, by after solving this problems. Okay, question number 9. So the mark is actually 6 marks. Step-by-step procedure. What is step number 1, step number 2, step number 3, etc. So you have to write the steps in your notebook. Then here, yeah, this is Gauss seeded. Okay, so that was all about today's session. So you have to complete all these problems in your notebook, and you have to submit this this as a, you have to take a photographs and convert this document into a PDF, and you have to share this. Thank you.